Hey guys, what's up? So today we're going to take a look at a new workshop where we're going to basically create a journal. And this workshop's going to really leverage what's called PDAs on Solana. So I'm going to show you guys how it works and then I'll explain what that means. So let's just say Larry's journal, right? And I'm going to go to create this journal. I'm going to be asked to approve this. I'm going to have to pay the transaction fee and the rent for the journal. And then now we're inside Larry's journal. And the thing is, our journals are going to be one to one, right? So each person connects with their wallet, they get one journal, right? So like you can't have more than one, at least in this situation. So every time I refresh, you can see it's going to load my journal every time. And then if I just type an entry, again, I'm going to be asked to approve to create this entry on the chain. And once I do that, it'll pop up. And then I can type some more entries, right? Hello there again. And every time I'm going to be able to create new entries under the same journal. So what we have here is actually indexed data, right? So we've got a journal that maps to my wallet's public key. So you know it's my journal. And then every entry that I create for that journal is indexed under that journal, right? So when we load the journal, we know we can load all the entries for it. And I'm going to show you guys exactly how you can do that and how you can set up your data and how you can set up your accounts so you can have indexed data that's queryable and loadable, and you can make something like this. Now, never mind my amazing UI skills, because I know this is very fancy UI, but I will quickly mention that I did build this using the Solana DApp scaffold. And I've mentioned this in a few other videos, so I'm not going to go into extreme detail, but basically you can find this in the Solana Labs DApp scaffold repo. It comes with a bunch of boilerplate code. It comes with some pre-configured like Next.js stuff. You can see it looks different now because it's recently been enhanced, but this was the old layout. But it's the same kind of thing, right? So it gives you like this wallet button. It gives you this airdrop feature. It gives you, some formatting stuff, some links and whatnot. And that's all just like straight out of the box. And there's a command that you can see in this image that basically says npx create Solana DApp and then the name of your DApp. And it'll actually spin this thing up for you. It'll also give you, a directory structure for building a program too. So it's up to you if you guys want to use this. It's a very useful tool. So with that being said, I'm going to take a look at our app here and all this stuff here, all these files, all this different like folders and whatever, these are really what most of what you get from the DApp scaffold. So like this is going to give you like your wallet connection stuff. And then like here's like your nav bar, here's your footer, like all these other things, request airdrop, blah, blah, blah. So the only things that I really created was this journal component and then everything in this IDL folder. So before I get into some of the front end stuff, and I think I might also have a util. No, I don't. Okay. Before I get into all this stuff, I basically want to talk about what the program looks like. And so you notice that we've got this IDL folder, and it's not actually an IDL. Like there's no JSON in here. And that's because this is not an anchor program, right? So I've substituted an IDL for all of the work that you would have to do in TypeScript to basically get all of your Bohr serialization going and build the instructions that you're going to need for this thing. So this is how you do this kind of stuff with a native program. You can use the same concepts for the PDAs and the seeds, etc., and the rendering with an anchor program. But in this case, I'm showing you guys how to do it in native. So with that being said, let's take a look at our program, and then we'll circle back to our front end, right? So starting with the program, if we take a look at the journal program, you can see here's the layout for our repository. And starting with librs, processor.rs, right? Like this is where we kind of enter into the program. And you can see that there's two instructions we can have, creating a journal and adding a new entry. And like I said, we can only have one journal per user. So if you try to run this again with the same like wallet, it's going to fail, right? Because you can only have one. It's going to say the account exists already. But this one is designed to increment itself and create new accounts each time you run it. So let's take a look at how this kind of is structured. So to start, we'll look at the journal. And this is what's inside of a journal, right? So the nickname that we gave it in that text field, the authority, like whose journal this is, the number of entries in that journal, and then the bump. So let's quickly talk about what's going on here, right? So Nickname, understandable. Authority, understandable. Number of entries, that's just a count. So we'll come back to this in a little bit, but every time that you want to create a new entry, we're going to update this variable and increase it by 1 so that we can reference this account and we can know what number our current entry is that we're about to create. So hopefully that makes sense, but it'll make more sense in a little bit. So the final field here, bump. Let's talk about PDAs for a second, and we'll shed light on what a bump is. So basically, a PDA is an account that it has its address derived from the program's address, and you do that with a number of inputs called seeds. And because you're algorithmically creating this account's address, it actually is designed so it doesn't have a private key. So there's no private key that you have to use to sign. There's no private key you have to manage, right? Like nothing like that. Otherwise, like if you're creating a ton of these accounts, you'd have a ton of private keys and it would just get messy, right? So there is no private key. And the way that that actually works algorithmically is when you provide a bunch of seeds as input, you will get an address and it has to basically not fall on this curve. And this curve is a mathematical computation that basically determines whether or not an account's public key can and should have a private key. So in order to make sure that it doesn't lie on that curve and there is no associated private key, you add one more additional seed, which is just a U8 integer, and it will bump it off of that curve. And that way you know for sure it doesn't have a private key. And that's what this bump field is for. And in this case, we're going to store it in the account just so we can access it later. But that's going to be automatically done for you whenever you go to create one of these addresses. And I'll show you what that looks like. So for starters, I'm going to quickly jump to our app to show you what that looks like in this IDL folder. And then we will cover some of the other stuff that you see in here. But basically, if you take a look at the instructions for an init journal, right here is going to be that function that you use. And never mind all the other stuff for now, we'll come back to it. But this is going to be that function that you use to create one of these addresses. You're going to use public key.find program address. And you can see that we're just using the string of the word journal. And then we're using the person's wallet public key. And we're putting both of those variables into what's called a buffer, an array of bytes. And with those two things as inputs, hashed with our program's ID, we will get back an address and the bump that it used to kick it off the curve, right? So this is what that looks like. You can get this information from anywhere, right? As long as you use the same algorithm. So we can do it on chain and we can do it off chain. And that's what's beautiful about these things is if I know the seeds that were used to create this account's address, I can recreate it anywhere. So since this is somebody's public key that's going to be connected to my app, I already have that information. And the other thing is just a string constant, right? So I have both of the inputs that I need to figure out what address your journal lies at. So because of that relation, anytime somebody hooks in their wallet, I can just run this thing. And if it gives me back an account, I know you have a journal that exists already. If it doesn't give me back an account, I know you don't have a journal, right? And that's all that's happening right here when we refresh and it knows to load Larry's journal because I created it, right? So that's all that's happening there. We will come back to this more like front end client side code in a minute, but that's one of the features that PDAs introduce. The other feature where I talked about them not having a private key, that basically allows you to do like edits to the data and like modify some of the features about that particular account without anybody having to like provide a signature for that, right? The program can basically do it on its own, which is nice. So if we take a look at the init journal instruction in our on-chain program, you can see, and I'll also keep this state open as well. You can see that I've added for this state, for this account, some associated stuff with this impl command. And basically we've got that string journal as the prefix, right? And then to create a new one, you can see that we only take these 3 inputs and the entries always start at 0. And that makes sense, right? Like if we're creating a brand new journal, we want to start at 0 entries. And then when we go to create an entry, we will turn that into 1 using this increment function, right? So we'll just continuously upgrade that and add one to it every time a new entry is created. So when we go to initialize the journal, you can see that the first thing we're going to do is load up the necessary accounts that we need, right? So we need to know the address of that new journal. And I'll also pop open, I guess, our client side stuff as well, just to keep up to snuff with what's happening. So I'll slide this over here. Hopefully this doesn't look too wacky for you guys. But basically you can see that, oh, that looks a little rough. You can see that we're going to have that journal account, that payer, right? So whoever's paying for this rent, etc., and the system program. And over here is where we're actually creating the instruction, right? So these two things are identical. One's our client side, one is our on-chain program, right? So we can derive this address, and since we've derived it, we can pass it in for this guy, right? And then we also know the wallet's payer, like public key, so we pass that in as well, system program, etc. And then you can see the first thing we do here is we create a new journal metadata object. So we're going to pass in those parameters, and we're going to get back the journal object with entries set to 0, right? So you can see that I'm passing in some args here. Now the first arg is going to be the nickname of the journal. That's pretty easy. You saw the person fill that out on the front end. And that's what's going on right here, right? Like this is going to be our instruction args object. And another thing is the bump, right? Which we got here from find program address. So we've got both of those bits of information. The nickname comes from the user's input on the front end, and the bump is coming from this function. So we pass both those things in, but here's where things get kind of interesting. So if we take a look at our processor RS, and I'm going to get rid of this side-by-side view because it's awful. If you take a look at the processor RS, we talked about how we have two different possible instructions here, and they're both inside of this enum. Now, we can use Borscht to serialize this enum down. Even still, because this enum has variants that accept arguments in the form of a struct, we can still use Borscht because what we did was basically said, this is also serializable, right? So now you have an enum that is serializable down to bytes using Borscht, or deserializable from bytes, that has a variant value, which is just a U8. And then it also has the, following args that are in the case of init journal, they're in the shape of this struct here. So what we can do on our client side then is we can actually create those inputs in a class, right? Where the first field is going to be that instruction, and it's just going to be the same enum. It's just like TypeScript doesn't support it in the same way Rust does, where you can write like a struct inside of an enum variant. But it's nonetheless the same thing if we just choose enum variant 0 and we put that as our instruction field, and then we have the rest of our args, then this is totally going to work, right? And so that's what's happening here. We know that this is going to be enum variant 0 with all of its ensuing args. So in Rust, we can just match that enum variant and then pass the args into our function call. And you can see here, like instruction, I'm going to try from slice. I'm going to try to deserialize the input into one of these two enums. And Rust will let you actually turn it into, it will actually let you match on the first like bit, right? It'll let you take a look at the first byte, I should say, to grab your enum variant. So it's going to look at the first one and say, is it 0 or 1? And then if it is 0, allow the args to go to init journal. And you can see from our IntelliSense, it knows that init journal args is going to be the type if it matches on that variant. Whereas on the other one, if it matches on the new entry instruction variant, it's going to be new entry args. So that's a pretty neat little trick. You can just like use a Rust match statement on the variant itself and have all these args packed in there. So on the TypeScript side, though, that looks like this. You just put the enum variant first. You build your schema. You can see that it is a U8 for that enum. And then we wrote these functions that allow us to go to and from buffer. And all that's really going to do is use the Borscht library and this schema that we defined to turn this class object into bytes or deserialize from bytes, right? And so the to buffer one comes into play because when we build our transaction instruction for the program, for our specific program, you can see we pack our keys in there, we pack in what our program ID is, and then we create this object with our parameters like we talked about and just run to buffer and then it's done. It's a buffer. And with doing that, we pass that instruction as a buffer of data, and then our program can then do this and read it and pick out whichever one of these, enum variants that's going to be with all of its associated args. So that's pretty cool. And that's what it's going to do, right? So that's the init journal, TypeScript function over here. So I'll close that out. We'll talk a little bit more about what's happening in the steps here for initializing a journal. And then the other stuff for the entries is going to look very similar. So we left off here where we created this object. And then we just go ahead and calculate the rent right here based on the size of this object, right? And once we have all that information, we can go ahead and use invoke signed to create that account. Now, here's where the concept of a PDA comes into play. So we know that this account, this journal account, isn't going to have a private key. It's going to be built using these seeds that we talked about, right? And so here they are in action again, but this time you can see they're being passed in this field as signer seeds, right? And that's because this is a PDA that needs to sign for its own modification, right? So we're going to create this account. And anytime you create an account, you're registering it with the system program, and then you're allocating some space to it, you're funding it, and you're setting the owner field. So you're making some modifications to it as you're creating it. And so in previous examples or in like some reference implementations or wherever you might have seen invoke without invoke sign, you usually required the signature of whoever this from public key is going to be and also this to public key. But if the to public key journal has no private key, we still have to use the seeds computation to actually authorize these changes. So you can see here, we're using the same seeds that we're familiar with, right? So the word journal, we've got the payer, and then we add the bump as well, just to add that number to ensure that this is, whatever bump we needed to make sure that this address was off the curve. That's the one we need to include here to actually do this computation to authorize a change. So long story short, guys, you can authorize changes and you can create signatures, so to speak, with a PDA that has no private key using just its seeds. You can just pass them in and the computation will run here to do some validation and allow a change, right? So that's how it works. And then once this is successful and we've created this account with no private key and it's going to store our data for our journal, right now at this stage, it only has the necessary size. It doesn't have any data in it. So what we're going to do is we're going to finally do serialize, and we're going to serialize that object into that account's data, and then we're done, right? So those are the steps, and they're going to look very similar for creating a new journal entry. So I'll pop that open as well. And first we'll take a look at the entry object. You can see this looks exactly the same, right? We've got a seed called entry this time, and then everything else looks the same. So what number entry is it? What's the message we're putting in there? What journal does it belong to? And what's the bump for this account, right? Again, being serializable. So this looks pretty similar. The new entry function where we're actually doing these steps is where things are going to look a little bit different, right? So conceptually, it's pretty much the same. We load our accounts up. We go ahead and get a new object for the entry metadata. We calculate the rent and size. We use invoke signed to create it, and then we serialize into it. But here's where we have some additional steps going on, right? So you can see that there's more than one serialization happening at the bottom. And you can see that we've got an additional seed compared to our journal, right? And then we've got some other stuff up here, an additional account. So the way that this thing kind of works is we're using a counter field to determine how many entries that a journal has. So because we're doing that, when we go to create an entry, we want to reference the journal that it belongs to so we know what number the current entry is, right? So like, for example, if the journal has 0 entries and we're creating one, we want to load that journal take a look at how many entries it currently has, which is 0. And then we know that our entry is going to be entry number 1, and so on and so forth, right? Entry number 2, 3, 4, it's going to go in the same flow. So for that reason, in our instructions, we also want to load the journal as an account as well, so we can reference it. And the args look pretty much the same, right? Instead of nickname, we have message, and we also have bump coming in, and that's so we can do our signature. But we'll get there. So anyway, we start by loading the journal up, and then we load the data from the journal. And then we can take a look to make sure that the journal's owner, the authority, is the same as the payer that's trying to create this entry right now. That's just a quick check. And then we can see here, entry number is equal to journal account data dot entries plus 1, right? And that right there is how we know what number entry we're on. And so from there on out, everything is the same as the journal entry, right? Or the journal creation. Set up the object, get the rent, create with invoke signed, right? And then serialize. And once that's all successful, then we go and increment our journal account data's entry number and serialize that, right? So we save that. And we make sure that this number is equal to the one that we've just created for this entry. Okay? So pretty straightforward. The only additional like missing piece here is I've actually changed the seed schema for this account, right? So if we look at our client side stuff for a new entry, you can see that here's the journal one as well in here. So we've got these two seeds, the payer's address and the journal's seed prefix. When it comes to entry, we've got the entry seed prefix, the entry ID, the entry number, and the journal's address. Now, this could be journal's address or it could be the wallet address. It doesn't really matter since our journals are one-to-one, but I just chose to use the journal address because we're going to load that account into our instruction anyway. So either way, you can see that this seed setup allows for us to use the same pattern for multiple entries, right? Because the journal address is never going to change and the entry string is never going to change. But if we want to create more than one entry, we need to have a seed that does change. And that's what we're going to use the entry count for, right? So every time we have a new journal or a new entry, we get a new entry number. And therefore we get a new seed that goes right here in seed number 2. And we get a new address. But we'll also get a new bump, right? So we're going to use that to pass in as well. But that's how it works, guys. So now you know that like every time we create a new entry, here's how we can have a seed that's going to update every time we have a new entry, give us a new address, and allow us to create a new account with new data. And this is kind of how you can mimic records, right? So like we have a table of journals and each wallet address has one journal. So there's one record per wallet address in the journal table. But then you have a table of entries where they have a foreign key that points to the journals table. And you can create a number of entries that all have a foreign key pointing to the journal, right? So one journal, you can search all entries by their journal ID, journal address, whatever. And the way that we're able to do that on Solana is if we have seeds that allow us to dynamically create more and more of the same account. So that's how you do it. And there's actually a couple different ways you guys can map this out and set up your data relations. This is just one example of like a pretty easy and common way to do it. But again, this is going to allow us just to create more entries under the same journal. And because it's a count, we also know like when they were entered, right? Like we can load who was first. So pretty cool stuff. And then, the rest of this, instruction building looks pretty much the same as the create journal one, right? We set up the object, we run to buffer, we build out the keys and build out the instruction. And you can see we're also using a schema. And in this case, we have message and bump. But finally, you can see that in this case, we just set the enum variant to 1, new entry, right? So that's it. We just looked at our program and we looked at the instruction building process on the client side to hit this program's instructions to do those things. So just to quickly recap, we've got our initialized journal instruction. This is what it kind of looks like. That maps this top part, this class and these functions and schema will map to this right here, initialize journal args, and then allow us to run all this stuff. And it'll make sure we have each of these accounts. And then new entry, same kind of deal, right? We've got the fields up top here. We've got the enum for which instruction it is, the schema. And then we can build the instruction down here and pack in the necessary accounts, including the journal. And notice how we get as an input the payer, right? The person's wallet. Just like before with initialized journal, we still have the payer's wallet coming in as a parameter. And from that, we can determine the journal and we can determine the entry. And so then we just go hit this bad boy. We've got these args, right? And everything steps through all the same. And that's really it. It's a pretty basic program. It allows us to create one journal per user and many entries per journal. So with that being said, that takes us to our React component here. And just to show you guys the rest of this IDL folder, like I've just got the state representations as well for the on-chain stuff. And this is just so we can deserialize into our front end. So it's going to look exactly the same as the Rust versions, right? And so that's actually what we're going to do, right? So on click create journal, we just get that instruction from our util function that we saw in IDL. So we're just going to get that back. That's going to be our instruction. We're going to get back two parameters, right? So the instruction and the public key of the journal, but we're not using it in this case here because I'm going to derive, right? But either way, this is going to be us creating a journal. We put that into a transaction and we send it with the wallet adapter. So that's going to prompt the user that's connected for a signature, which we saw. And then I'm going to run get journal. And the reason I'm doing it this way is because A, I want to make sure that this is confirmed, and B, I want to show you guys how we can, again, use the same like C derivations to get our journal on the client side with the connected user's wallet, right? And it's just the same function, right? So find program address, the wallet's public key that's connected, and the word journal. And this is going to actually get the person's journal and then parse it using that from buffer function into the journal's data, which you can see is going to be of this journal metadata class type. And then we just return all that data as a store so we can access all that information. And the same thing goes with any of the entries that we have. But here's where things get different, right? When it comes to the entries, because we used an incrementing counter, what we can do is first use the same function to get the journal. And then we can take a look, just like when we're building that instruction for a new entry, right? We took a look at what the current entries count was, and we incremented it by 1 to determine the current entry count of the new one to be created. In the same kind of fashion, what we can do is we can, if I open this use entry store, we can then get that entries field again, but now we can iterate over it starting at 1, and we can derive each of the addresses for that entry, load them up, parse them from buffer into an entry metadata object, and push them into a list, right? And so once we get to the max entry count, we stop and we have all the entries. So there's a function called get program accounts that you guys can run. And that'll just give you a dump of all the program owned accounts. And then you can filter it based on the data setup, like what the schema is for the data, who the owner is, like all these other fields. But that can be a little bit computationally intensive depending on how you run it. So with this strategy, at least until we end up with a ton of entries, this is actually going to be a little bit faster. It's going to be an optimization because we can derive the address and then just do an RPC call for one account, which is going to be relatively quicker, right? Like I said, once you scale this out and you have a ton of entries for one person's journal, like maybe thousands, it's probably not going to be any faster. In fact, it's probably going to be slower. But for a very like short demo purpose, this is exactly how you can do that with only a few entries quite quickly, right? Especially if you only need to load my entries and you don't care about anybody else's entries. This saves you a lot of overhead. But either way, we parse that out, we push it into a list, and that's how we get to this point where we're loading our person's entries, right? And guys, that's really it. Like that's the extent to how you do this. So the code is available. You can take a look and reference again. But the ultimate point is we just have data mappings laid down with our Solana on-chain accounts. And they allow us to create functionality for our front end and create index data. So we laid down a one-to-one mapping of journals to users. And so if I switch my wallet, you can see that like that journal is going to go away, obviously, because this is the only wallet that I've created it with. So this will allow me to create a new journal, hopefully. And then, yeah, so you can see there's my rent. And then if I just flip back, you can see it's 1-to-1, right? One wallet has one journal. And we also want to allow multiple entries per journal, right? So that is how we laid that part down as well. We created an entry counter on the journal itself, and then we had the entry number be sort of like the ID, and we use that to create new entries at will, and we can create them all the way until I think we used a U32, so the maximum allowance of a U32, right? That's going to be where we max out for how many entries we can create. And you can make this a U64, you can do whatever you want. But that's really it, guys. That's dynamic index data on Solana. I know it's a little confusing with the whole like seeds and everything, but if you can figure those out and get that down, then it's actually really easy to build index data that's queryable and optimizable in a lot of different ways. Cool. Good luck.